So in this video, we're going to be looking at subtractive synths. Now I'm going to be using this analog subtractive synth in Ableton because this is the one we're going to be using for our task at the end of this lesson, okay? I'm going to take you through the main components, what they do, and the basic routing setup for this synthesis, okay? Now remember, when I talk about subtractive synthesis and all of its components and its routing, this isn't just relating to this one analog synth that we're looking at. This relates to all subtractive synths through all of the different DAWs. The only main difference is that they will look different, okay? So all of these tools that we're going to talk about and use today, you can use in a variety of hardware and software subtractive synthesis. The only main difference is they will look different, okay? So three main components, what are there? So there's an oscillator, a filter, and an envelope. What does this mean in practice, okay? So our oscillator is basically where we're going to get our sound source from. It's going to be our waveform, our sine wave, our square wave, our sawtooth, our triangle, etc., okay? Which is coming from our oscillator. Other people like to call this a sound generator because it is the birthplace of our sound signal. Okay, next we have our filter. Our filter is going to filter out certain frequencies, and this is where we're going to start to hear sort of more tonal aspects and to start to shape our sine wave, okay? Then we have our envelope. It is going to determine the speed in which the waveform is becoming active and then how it's outputting. So this is going to relate to our ADSR, our attack, delay, sustain, release. Let's use this in practice. Now, let's just start to hit some notes. So we hear a sine wave, okay? Let's pull our filter down. Now, there's not much definition in that sound, so I'm going to change it to a more complex waveform so that there is more definition when we start to move our filter. Okay, let's put that to about 1K. Yeah, and then when we start to move our resonance up, we'll hear that we get a peak at 1K at about 70%, okay? And then obviously, if our amp is turned off, we see our signal coming in, but we see no signal coming out. So it needs to be on in order for our sound to be heard. Okay, lovely. And then if we reset everything, okay, and switch on our second oscillator, let's put it back to a sine wave, so just for this example. So obviously with one oscillator being on, we just hear a simple sine wave. If we switch our second oscillator on, our sine wave is just going to be slightly louder, okay? So we need to start thinking about how we're going to use all of these different tools to create a complex sound for our task, okay? Now, another cool thing about subtractive synths and synthesizers in general is the routing. Routing is really where we're going to start to hear a more developed sound, okay, from our waveforms. So this first little bit on this particular synthesizer is F1, F2. Now what does that mean? That means filter 1 and filter 2, okay? So what we can do here is we can actually send oscillator 1 to oscillator 2, meaning filter 2 will now start to affect the sound of oscillator 1. And then again, the same with oscillator 2. Filter 1 can affect the sound of oscillator 2. So how we're going to do this is we're going to just send all of the signal to filter 2. Okay, let's turn oscillator 2 off because we don't need that at the minute. So let's just start to play a note, okay? So we have our oscillator 1. If we start to move filter 1, we don't hear a difference. There's nothing being heard, okay? But if we start to move our filter 2, we can start to hear a bit of a difference. That's because filter 2 is controlling the signal of oscillator 1, okay? Perfect. And then same again, if we use oscillator 2, we send all of its signal to filter 1. Oh, let's get that up there. It'll do the same. It will affect the sound of filter 1. Cool, right? So we're starting to look at signal flow when we use F1 and F2, okay? So the signal flow and how it's running at the moment is just quite linear. So whenever we reset everything, put oscillator 1 back to F1, this basically means that oscillator 1, its waveform is going through filter 1, it's going to amp 1, and because the LFO is switched off, it's not going to affect it, and then it's going straight out to the main output, okay? Now if we turn the LFO on, it's going to go oscillator 1, filter 1, amp 1, through to the LFO and then out to the main output, okay? And then same again with oscillator 2. The signal flow is going from oscillator 2, filter 2, and then through to amp 2, and then out to the main output because our LFO isn't switched on. So that's our basic linear A to B to C to D signal flow and how it's working in this synthesizer, okay? And remember, this applies to all synthesizers. The only main difference is that they look different. On this synthesizer, we have a really great way for quick routing, okay? So what are all of these different little things here that we see? So as I start to click on all of these, we can see that things are turning off and turning on. So that's our routing and our signal flow working in practice, okay? First of all, we have this one here, OFA. First of all, what does that mean? It means oscillator, filter, amp. So that's basically what we just talked about. That's our basic linear signal flow, oscillator 1 flowing to filter 1, amp 1. The second one here, we see that filter 2 and amp 2 has switched off. Now, with filter 2 and amp 2 inactive, this means that oscillator 2 needs somewhere to go in order to be heard. We can see here that F1 and F2 option has been changed for the whole signal of oscillator 2 to go into filter 1. This means that oscillator 1 and oscillator 2 are meeting at the same point and using filter 1 together, okay? This also means if we turn off amp 1, we won't hear any signal at all. Next, we are going to look at this one. Okay, both oscillators are splitting its signal by half. So if we look here again at F1, F2, both oscillators have 50-50 on it. That means that oscillator 1 is splitting its signal equally with filter 1 and filter 2, and then the same again with oscillator 2. It's splitting its signal equally with filter 2 and filter 1. In this one here, we can see that amp 1 is switched off. So this means that oscillator 2 is being sent to oscillator 1. They're both going to filter 1 and then down to filter 2. Now it's been able to do this because of this little to F2 option here. We can send some of our signal to F2 or we can send all of our signal to filter 2, okay? So that's what that's doing. Our signal's going from oscillator 2 into oscillator 1, filter 1, down to filter 2, amp 2, and then to our main output. So overall, we know what each section does individually, but it's when we start to put things together and change the routing options and change our waveforms and detune things when we start to get a complex sound, okay?